In this Blender tutorial, I am going to show you how to sort the indices of your point geometries using one of its attributes. Here, you can see the difference between a sorted and unsorted point geometry. First, I'm going to create some points in a volume to demonstrate this workflow. I've created a new cube, converted it to a volume using the Mesh to Volume node, and then convert the volume into an array of points using the Distribute Points in Volume node. You can see if I connect up a viewer node to the points I just created, the indices are ordered sequentially, but the position of the points is random. Next, I'm going to sort these points according to their y value by passing a position node into a separate xyz node. I'm then going to pass the y coordinate into this node group called Sort Index by Attribute. You can sort your points by any attribute you like. It doesn't have to be the point position. The node group also takes the original point geometry as an input. If I tab into the node group here, you can see a collection of nodes intended to sort the points by a particular attribute. Some of these nodes are only found in Blender version 3.4 or above. I'll give you a second to copy this node diagram into your own project and then we will continue with the tutorial. The output of this node tree is an integer array specifying the indices of the original points which are sorted in ascending order by the specified attribute, the y-coordinate in this case. If I connect up the original point geometry into a viewer node and connect the index up to the value, you can see the original order of the indices in their sequential but unsorted state. But if I connect up the sorted index output from our new node tree, you can see the new points indices. The indices of the first 4 points corresponding to the smallest y values are 0, 4, 5 and 12. Now that we have our sorted index array, we want to be able to animate the position of another mesh along the sorted path of the original points. To do this, we need to create a new node tree and pass in the sorted index array. We also need to pass the original point geometry as an input. If we tab inside this new node group, called getPositionAtIndex, you will see a collection of nodes designed to give the coordinate of a selected point from our sorted array. I'll give you a second to copy this node tree into your project. To demonstrate how this works, I'm going to create a UV sphere and a transform node and set the translation to be equal to our position of the sorted points. Then, I'm going to combine by UV sphere geometry node tree to my original point geometry using a join geometry node. I'm going to reduce the radius of the sphere so it's a more reasonable size. You can see that the UV sphere has now been placed on the point with the lowest y value. I can now increase the selected index property to move the UV sphere between my original points but with the movement sorted in the y-axis. You can see if I plug in the original, unsorted index list, the UV sphere jumps randomly between the points. I'll reconnect the sorted index list back into the node tree. Finally, to animate the sorted movement, I'm going to connect up this scanning speed node group to the selected index property of my node tree. This node group provides the frame number from the animation timeline and will move the UV sphere by 1 point per frame. When you press play on the timeline, the UV sphere moves automatically by 1 point per frame in a sorted fashion.